Hello, very good morning. Today I'm excited to present our innovation title or final project. Our project is Green Walkway Pathway for Sustainable Energy Investing. Okay, this project focuses on converting kinetic energy from footstep into usable electricity using piezoelectric sensor, an eco-friendly solution aimed at promoting clean energy in urban infrastructure. Okay, first of all, my name is Aidil Azimir Nazwazlan. I'm from Group KA21, and my teammate.
My name is Iluman Hakim Nenek Aziz.
My name is Praveen Analaki Mutubu.
Now, let's look at the problem statement. First of all, to understand what's going on, we have to look at the statistics. The pie chart shows the US primary energy by energy sources in 2023. By this, we can see that renewable energy only amounts to 9%, while the rest are non-renewable energy. The other graph shows the total energy consumption of the world in 2023. As you can see, the energy consumption has increased drastically in the past 23 years, and it will only continue to increase. This is because as the population of the world increases, the energy demand also increases. Due to this, reliance and demand on non-renewable energy increases. This is because non-renewable energy such as nuclear energy produces a lot of energy. To put it in perspective, one nuclear power plant is enough to sustain 8 million households. Even though it produces a lot of energy, it causes significant amount of environmental harm, such as nuclear waste being dumped into rivers, causing water pollution. So it is necessary for us to find a suitable replacement. Urban areas have a large population, which creates a lot of movement. This presents an untapped opportunity for energy that can be harnessed. For example, the movement are kinetic energy which can be turned into energy, and the kinetic energy from movements is currently being wasted. So, we plan to create a device to collect this energy. This project aims to address these issues by designing a platform that can harness energy from daily human movement. By demonstrating the feasibility of this approach, the project contributes to the development of sustainable energy solution that runs on clean energy.
So for the project objective, there are three. The first one is to design a prototype energy harvesting platform. The second one is to determine energy produced from the footsteps into electrical power. And the last one is to project the potential application of the piezoelectric system in terms of energy consumption.
Okay, for the next slide, our methodology outline the step-by-step process of developing the Green Walkway prototype. We begin by identifying the problem and setting clear objectives. Then we move into the design phase where we create the circuit using piezoelectric sensor, LED and battery systems. Okay, for the next slide, the goal of the design is to create a structure that allows the piezo sensor to detect mechanical stress efficiently while being protected and supported by surrounding material. Each layer plays a specific role in signal transmission, cushioning and structure integrity. Okay, the topmost layer is a 5 mm thick blackboard. This serves as the contact surface where pressure or vibration is applied. Directly beneath the board is the 2 mm piezoelectric sensor. This is the core sensing element. When mechanical stress is applied, it generates a voltage signal proportional to the force. Okay, next is a 100 mm thick fourth layer, shown in white, form as a mechanical buffer, absorbing excess force and preventing damage to the sensor. Okay, for the last layer is base layer, wood 100 mm. The bottom layer is 100 mm thickness wood, which provides structural support and stability. Let's look at the figure below. In the setup, we use 60 pieces of piezoelectric sensor arranged in 3 parallel strips, each spaced about 10 cm apart.
Alright, so as for the solutions, we run a test on our platform at our own institution in Polytechnic in order to capture the number of steps produced among all of the people there. It is to collect data projection between energy produced and cost efficiency. Basically, to explain the working mechanism of our project, when people step on our platform like this, the pressure from footsteps will generate mechanical stresses on the piezo sensors beneath the platform surface. And then the pressure from the footsteps will generate mechanical stresses on each of the piezoelectric sensors. Next, each piezoelectric sensors will react by converting the mechanical stresses into small electrical voltage. This electrical voltage will then be collected and stored in rechargeable batteries. And lastly, the stored energy can be used as backup or main source of energy in order to power low appliances like LED lightings, smart signage, and others. If the backup energy from the battery has been fully used, the same method will rotate from footsteps and charge the used battery. To prove that, we ran a test for about roughly 1 hour in our polytechnic in order to capture numbers of steps made on it among all of people's there. So as you can see, we earned 500 steps where each steps could generate about 0.1 to 0.8 voltage per steps. This means that if we run a test on peak hours, for example 8 a.m. to 12 p.m., the more steps and voltage could be generated since most of people will use the pathway to get to classes, cafes, and others. We also use small lamp for represent as LED lighting in real highway or pathway. Other than piezo sensors itself, there are few main components that we use such as battery in order to store harvested electrical energy for later use, and rectifier circuit to convert AC to DC. In this part, it is very important to protect other electrical components and preventing damage from voltage spikes. And also last but not least is LED, which is to utilize the stored energy as powering the lights. Here is the projection. Each steps produce voltage between 0.1 and 0.8 volts based on characteristic of piezoelectric sensors. This translates to roughly 0.005 joules. And these are the basic conversion to get WH, which is watt times hour. Overday approximately can reach 2,500 steps per platform. So when we're scaling to hundreds or thousand platforms, especially on busy areas such as MRT or LRT, for sure it is enough to power up pathway lighting or smart signage for several hours daily. For example, one platform that receives 2,500 steps can get 12.5 joules of energy per day. When we convert that to WH, it collects 0.00347 WH per day. Then we repeated the same calculation for larger scales, for example, 10, 100, and 1,000 platforms, to estimate how much energy could be harvested in a larger area. So, based on this projection, basically 360,000 footsteps would be needed to power one small 0.5 watt LED for an hour. So for one platform, it is enough to power 0.5 watt of LED for 25 seconds. And if we scale up the system, the output power becomes more meaningful.
Now, I'll continue the presentation with the impacts and benefits. First of all, let's look at the impact. This project relates to 4 out of 17 Sustainable Development Goals. First of all, SDG 7, affordable and clean energy. It ensures access to affordable, reliable, sustainable, and modern energy for all. Next, SDG 9, industry, innovation, and infrastructure, which is to build resilient infrastructure, promote sustainable industrialization, and foster innovation. Moreover, SDG 11, sustainable cities and communities. It makes cities inclusive, safe, resilient, and sustainable. Lastly, SDG 13, climate action, which is to limit and adapt with climate changes. As for the benefits, first of all, it helps to save costs. When implemented in a heavy foot traffic pace, for example, we suggest an LRT or FRT walkway, it can reduce electricity costs. This is because, based on studies, on average, there's about 83,500 people using them per day. Furthermore, it promotes renewable energy use. By integrating renewable energy system in public transport areas, it highlights the commitment to sustainability and innovation. It helps reduce reliance on grid electricity and lower carbon emission. Last but not least, it helps with environmental sustainability. By producing green energy, it helps lower pollution and minimize environmental degradation.
The next slide, let me see for conclusion. Okay, the conclusion, the Green Walkway project is more than just a prototype. It's a step toward a cleaner and smarter future. By using piezoelectric sensor, we will show how human footsteps can be turned into renewable energy. Okay, this innovation help reduce our dependence on fossil fuels and support the move toward sustainable technology. In short, our project proves that simple ideas can create real impact for greener works. That's all for our group. Thank you.